Hi, my dear friends. Welcome back to another Python tutorial class. In this class, we shall look into the other types of operators. In the previous class, we had started with operators. Now, in this class, let us look into the other operators. For example, we have membership operator. Okay, membership operator. Now, what are the rules about membership operator? Like, for example, number one, it inspects whether a particular element is the member of a container or not. Container means like iterables. Iterables like we already have discussed, for example, string, list, tuple, etc. Okay. So again, membership operator, it will inspect whether a particular element is the member of a container. Container means iterables. For example, iterables mean like string, list, tuple, etc. Okay, so a membership operator will inspect whether a particular element is the member of a container or not. Then the second thing about membership operator is it returns a Boolean output. We know what is Boolean, true or false. Then third point is string, tuple, list, dictionary, range, frozen set. These are all iterables. Okay, and containers you can say as a result. Now, what are the two types of membership operator? Like if you go into the classification of membership operator, then membership operator has got two classifications. There are two types of membership operators. One is in operator and the other one is not in operator. Okay. So in operator is a membership operator and not in operator is another type of membership operator. Now let us see some examples. For example, here you have str1, a variable to which the string value is assigned. What is the string value? The word programming. The word programming. Okay. Now how to basically check whether some particular elements are part of this particular container or not? Because ultimately this is an iterable only. This is an iterable. So this variable contains an iterable. Okay. Now, how to check? Like print, then here you have capital N, then this operator, in operator. This in operator is this one. Okay. So here you have to write this keyword in. Here you have to write this keyword in, then give this name of the variable where it contains this particular string value, where the string is an iterable, which is a container. Okay, and that is stored here in this variable str1. So what it will check whether this capital N is whether this capital N is a member of str1 or not. Now let us check in this word programming. Anywhere do we have capital N? We do not have capital N. So that's why N here, capital N here, is not a member of str1. That's why here the output says your false. Okay. Then the next part is print, then small n. In, here I'm using the in keyword, that is for the in operator, in str1. So what it will check? It will check whether this small n is a member of str1 or not. Now let us check in programming. Anywhere do we have small n? Here we have, yes, here we have this small n. So it is indeed a part of, it is indeed a member of str1. Okay, so that's why here the output is true. And we know that this membership operator always returns Boolean value. Then the next is print capital B in str1. So is capital B a member of str1? Now in str1 we have this word programming string, which is basically a string word, which is an iterable, a container, whatever you can say. Capital B is not a member here. Capital B is not present in this programming. So capital B is not a member of str1. So that's why it returns false. Okay. The in operator will only return true when a particular element is a member of the container. Then only the in operator shall return true. Otherwise, it shall return false. So just run this cell and here we go. Then let us look into this particular cell. Here you have L1 variable. Inside you have list, and inside the list you have these heterogeneous elements. For example, first you have this boolean value true, then here you have this integer 15, then here you have this string value company, then here you have this set. Inside set you have these three elements 10, 20, 30. Now one thing you must always keep in mind while doing programming in Python, that is the first value inside this container whether be it a list, tuple, string, anything, that shall always start at index position 0. Okay. So here true, it basically lies at index position 0. Then the next 15, this is the second value. This will lie at index position 1, or it lies at index position 1. Then this company, it lies at index position 2. Okay. And then here you have the last one, which is your this set, this entire set. This entire set lies where? This entire set lies at index position number 3. So how many components this L1 has got? It has got 1, then 2, then 3, and then 4. Okay. This is the fourth component. This set is the fourth component of L1. Okay. So there are four components. First, second, then third is company, fourth is this set. And as I have already told you that the first component of any container or any iterable, it shall lie at index position 0. Then the second component will lie at index position 1. Then the third component will lie at index position number 2, and so on. Like the fourth component shall lie at index position number 3. Okay. And so on. That's how it goes on. Like if you have 100th component, then it shall lie at 99th index position. Okay. Now if you go inside this set, uh, inside this set, if I'm talking about, then here your 10, it lies at index position number 0. Then 20, it lies at index position 1, and 30, it lies at index position 2. This I'm talking about when you're going deep into this set. When you're inside this set, there are three components. This is the first component, which inside the set lies at index position 0. This is the second component, which lies at index position 1. This is the third component, which lies at index position 2. That's why here you see 10, here the 10, which is the first component of this set, lies at index position 0. 20, which is the second component of this set, lies at index position 1. And 30, which is the third component of this set, lies at index position 2. Okay. Now let us check. Now let us apply the in operator here. Print 1 in L1. Okay. Now as you can see, L1 is nothing but your list only, and list is a container and iterable. Okay. So is 1 a member? Is 1 a member of L1? As you can see here, this true, the equivalence of true is nothing but 1. So yes, 1 is a member of L1, and that's why here you get the output as true, that yeah, in operator returns true, that yes, 1 is a member of L1 because there is true component inside this particular list, and equivalence of true is 1. Then 15, 15 in L1. So in operator, in this case also in operator shall return what? It shall return true. Why? Because here your 15, this 15 is a member of this particular list L1. Then print 10 in L1. Is 10 a member of L1? Anywhere do we have 10? Here we do not have 10. Here we do not have 10. Here we do not have 10. Now, inside this set, there is 10. Inside this set, there is 10. But if you want to access this particular 10, then directly you cannot write it like 10 in L1. Because why? Because here 10 is inside a set, and the set is inside a list. Okay, so that's why here it shall return false. It shall return false. If 10 would have lied here inside the set independently, then it would have returned true. But if inside a container you have another container, and then inside that inner container you have an element like 10, then directly if you give like this, print 10 in L1, then it shall return false. Okay. If 10 would have lied, suppose here independently, then it would have written true. You see, then it would have written true here, that yeah, 10 is a member of L1, but that is not the case here. Returning to our original scenario, 10 is not a member here. So how to do this? You see, print 10 in then L1 3. Print 10 in L1 3. Is 10 a member? Is 10 a member of this particular set? That's what it is trying to say here. Because L1 3 is what? Your L1 3 is what? L1 3 is nothing but the set L1 3. So what it will check? It is at the 0, this particular element. It is at 1, this particular element. This particular element is at 2, and this entire set is at index number 3. So this is how you can access a particular index. So L1 square bracket 3, that means your set. That means your set only. Okay. So now it shall check. Now it shall check, Python shall check only inside L1 3. What is L1 3? This entire set. Inside this, it shall check whether 10 is a member or not. So it finds out that yes, it finds out that yes, 10 is indeed a member of L1 3, where L1 3 is this entire set, and it checks out that yes, 10 is a member of this particular set. So that's why it returns true. All right. Okay. Then print small m in L1 2. What is your L1 2? L1 2 is your L1 2 is what? This is L1 0, which is true. This is L1 1, which is 15. This is L1 2, that is nothing but your company. And here company is an iterable. Here company is an iterable, that is a container. So already here this is a list, which is a container. Inside this you have another container, which is your this string, that is company. Okay, now I want to access this m. I want to access this m value of company. That means I have to go first inside the container, which is the list, then inside the inner container, which is your this string, which lies at index position number 2. That's why I've given here L1 2. So immediately Python will get access to this inner container, which is this iterable, that is string company, and inside this it shall check for the letter M, and it says that yes, M is indeed a member. M is indeed a member of L1 2, where L1 2 is your company. Okay, and company is what? A string, which is nothing but an inner iterable inner container inside this outer container list. Okay, if you're considering this list as to be the total outer container, inside this you have got containers, like here you have one container, and here also you have got one container. Okay, so if you want to check a particular element within the inner container of the outer container, then this is how you will have to give your commands, by accessing those particular index values of those particular inner containers. Okay, so it will check for m inside L1 2, where L1 2 is your company, and it says true that yeah, m is a member of L1 2. So just run this, and then here you have another, like for example, x is a variable. Inside this you have this dictionary. Inside this dictionary you have the keys to value pairs. This is a key, and this is the value of the key. This is another keys to value pair, where comp is the key and xyz is the value of this key comp. Then here you have another keys to value pair, where age is the key and the value of this key is nothing but your 39. Okay, so these are again hypothetical values I've taken. For example, you have got an employee, so emp underscore name, employee name, which is the key, and the value of this key is Anna. The employee name is Anna. Then you have this second key, which is your comp. What is the company where the particular person is working? This is the key, second key, that is, and the value of this key is xyz, that is the company name is xyz, hypothetical values. Then what is the age of the employee? This is another key, so the age of the employee is nothing but your 39, which is the value. So now let us check print emp underscore name in x. That means it's checking whether emp underscore name is a member of x or not, because this entire dictionary is assigned to x variable. So it will check whether emp underscore name is a member of x or not, and definitely yes, emp underscore name is a member of x, so it returns true. Okay, Then it checks print Anna. Now here, please remember Anna is the value, and already we have discussed this thing that in case of dictionary, directly the keys can be accessed, but directly the values cannot be accessed. For that, we need the dot values function. Okay, so here I am writing what print Anna in X. Is Anna a member of X? Now here it will check only for the keys. EMP underscore name, Anna is not here. Then comp, Anna is not here. Then age, Anna is not here. Okay, and that's why here the output is false. Now, so what to do? In that case, you have to do that thing which we have done in previous classes. That is, you'll have to use dot values. Values function you have to use. Print Anna in x dot values. We have already seen this application of values because in case of dictionary, you have to, if you want to access the values, you have to use the values function. Now it will check only inside the values of this dictionary. And here only it finds out that yes, Anna is present. Anna is present as a value inside this dictionary, and hence it returns true. Okay. Then now if I want to write print age in x dot values. Now age is what here? Age is a key. Age is not a value. But I'm giving the direction to Python that print age in x dot values. So Python will check whether age is a member of x or not, but inside the values only. It will check whether age is a member of x or not, but inside the values only. So it shall check age is here in the value. Is age a member inside this x in the values? It will check all the values. First value, age is not here. Second value, age is not here. Then third value, age is not here. So you have to go back to your traditional step, print age in x. By default, in this way, your Python shall look only into the keys. Separately, you can also use the dot keys function that also we have discussed. So now Python will check for age inside the keys of x. Here, age is not there in the first key. In the second key, also age is not there. Here, the third key, yes, age is there. So it returns your true. Okay. And in previous case, it returned false when we were checking for age inside the values of the dictionary. And then finally print 39 in x dot values if 39 is a member of x inside the values or not. So it finds out that yes, 39 is a member of x inside the values part. It is the third value, so that's why it returns true. Okay, so just run this cell. Yeah. And then next this cell. Here you have a string to which this company is assigned, and we already know that string is a container that is an iterable. Okay, and C is a part of this container. O is a part of this container. M is a part of this container. All these letters, these are the components of the container. What is the container here? String, which is the iterable. Now we have checked the in operator. Now let us check the not in operator. Print capital Z not in str1. So already I'm implying to the Python that Z is not a member of str1. Is it true or false? Okay, it's checking that whether Z, I'm just what I'm trying to imply to Python here is Z is not a member of str1, true or false, and it checks Z is not there, so it returns true that yes, Z is not a member of str1. Okay, now I'm trying to say here print capital C not in str1. That means capital C is not a member of str1. So Python shall check and it says no, capital C is indeed a part or indeed a member of str1. So that's why it returns false here because by default if a particular component or element is not a member here of if a particular element or component is not a member, then the not in operator returns true, otherwise returns false. So it shall I basically imply here print C not in str1 means C is not a capital C is not a member of str1, and whether it's true or false. Python checks that no, it's false because capital C is indeed a part of str1. Okay, not in by default, if it finds that a particular element is not a member of the container, it returns true, otherwise it returns false. Print small y. Print small y not in str1. So small y is not a member of str1. true or false. It checks that no, y is indeed a member of str1. That's why it returns false here. Okay, so this was about the membership operator. Now let us look into the identity operator. Okay, identity operator, what it does, an identity operator inspects whether two elements have the same memory ID or not, returns a boolean output, and the classification of identity operator is and is not. Like these is op is operator is a part or is operator is an identity operator, and is not operator is also an identity operator. Okay, and what I'm trying to say here is the memory address of the element is yielded by this ID function. Okay, ID function returns the memory ID or the memory address. Now let us check x is equals to 30, y is equals to 30. And here, as I told you, there are two types of identity operators. One is your is operator, which is an identity operator, and the second one is not operator. Print x is y. So that means what I'm trying to ask here, that the memory ID of x and y are the same. The memory IDs of x and y are same. There is x, the memory ID of x is same as memory ID of y. So it returns true. It returns true. In Python, you must remember that a value is always stored at a particular ID. For example, here you have this particular ID 269 or this ID. Okay. So wait a second. So this is say a particular ID. Okay. ID means address. Address. And in Python, in the addresses only you have the value stored. So here at this address, you have the value 30 stored here. Okay. Now when I'm trying to write here that x is equals to 30, it doesn't mean that x will store 30. It means that x basically stores, or x basically points to this memory ID where 30 is present. So it is like an inherent pointer concept inside the Python. Okay. Explicitly, you do not have to use pointers here in Python. Inherently, pointer is present here in Python. So that's what I'm trying to say here. This memory x is equals to 30. Whenever I do it, that doesn't mean that variable x will store 30. Rather, the variable x shall point to this particular memory ID where the value of 30 is stored, and then the inside the Python will go to this memory ID, and then you will get the access of 30. And same in case of y also. Like when I try to write, when I try, like here you give this ID again, and same ID only. Ultimately, same ID only. ID will be one. Memory ID will be only one. Here you have this particular memory ID where the value of 30 is stored, and x is equals to 30 will do what? X will have this memory ID, and x will point out to this memory ID, and after pointing out to this memory ID, 30 will be accessed. Same will happen with y also. Okay. So when I write y is equals to 30, that means y will have this particular memory ID, and it shall point out to this memory ID, and after pointing out to this memory ID, then the value of 30 shall be accessed. Okay. So here you have one memory ID, and at that memory ID you have the value of 30. X points out to this particular memory ID, and you have y also points out to this particular memory ID. And when both of them are pointing out to the same memory ID, then via both of them you can access the value of 30. That's what I'm trying to say, because x will have this memory ID address, and y will also have this memory ID address. And is operator returns true whenever the memory addresses are same. So here x and y, both of them have the same memory address. That's why here in this case the is operator, it shall return the true. It shall return true. Okay. And if you want to separately check out the memory ID values, then what you can do here is you can use this ID function. As I told you, ID function returns the memory ID or the memory address of an element, where 30 is the element here. Okay. So print ID of X. ID of X shall return this memory ID. Then print ID of Y. Print ID of Y shall also return this particular memory ID. And here both the memory IDs are the same. That's why it returns true. Now here if you come, now see X is equals to 12.5, Y is equals to 12.5. And what I'm trying to check here, print X is Y. That means memory ID of X and memory ID of Y, both of them are same. But it returns false here. Is operator says that no, the memory IDs are different here in case of X and Y. That's why it returns false. Why that happens? You see, inside X you have 12.5, inside Y also you have 12.5. So you can pretty easily say that the values are same. The values are same. So in that scenario, the memory IDs should also be same, because you might want to argue with the fact that there will be only one memory ID. Say suppose this one. This is the memory ID, and at this memory ID you have this particular float value, which is the element, that is 12.5. Now when I'm writing X is equals to 12.5, it means X is actually having this memory ID, and you can say that X is pointing out to this particular memory ID where you have this value 12.5. And same happens with Y also. Same happens with Y also, isn't it? Because same happens with Y also, because you see Y also, when you're trying to write Y is equals to 12.5, it doesn't mean that Y will store 12.5. Just like X is equals to 12.5 doesn't mean that X will store 12.5. Similarly, Y will also not store 12.5. Y will rather have this address, the same address, and and Y will point out to this particular address. At that address you will have this float value, which is the element 12.5, which can then be accessed. But in case of float value, this concept does not work. In case of float value, this concept does not work. Okay, because when you're writing 12.5, then this 12.5 at first will get created at this memory ID. And when you're writing X is equals to 12.5, then actually X will be having this particular memory ID, and so X will be pointing out to this memory ID, and at this memory ID 12.5 is there, which will then be accessed. Okay, inherent pointer. Now again here I'm writing 12.5. Now in case of float value, what will happen is a new memory ID will be created. In case of float value, a new memory ID will be created, say this particular value. And here again 12.5 will be created. Here memory ID got created only once, where it stored the value of 30. Okay, and both X and Y were pointing out to this same memory address, because both of them were having the same memory address. That's why return true, this operator, which is an identity operator. But in case of float value, the system does not work like this. Here, at first, when you have created 12.5, then this 12.5, it shall be created at this memory ID. And when you create this 12.5, y is equals to 12.5 means again you're creating 12.5, then 12.5 will be recreated here. 12.5 will be recreated at a different memory ID. So in reality you will have two 12.5 values, one 12.5 which lies here, and another 12.5 which lies here. Okay, this at this particular memory ID. So now what will happen, X is already having this memory ID, so X is pointing out to this particular memory ID where you have 12.5. And what will happen to Y? When I'm writing Y is equals to 12.5, that means Y will be having the second memory ID which got created. Y, when I'm writing Y is equals to 12.5, then actually internally Y will be having this particular memory ID. It won't be having the value. Okay, and Y will be pointing out to this particular memory ID, and then at this particular memory ID you have this second 12.5 value, which will now be accessed. So that's why here it returns false. Print print x is y. The print x is y means I'm checking that whether the memory IDs of x and y are same or not, and that's why is operator returns false, that no, a memory ID of x is different from that of memory ID of y. As you can quite clearly see here, the memory ID of x and memory ID of y, they are different. That's why returns false. This happens in case of float value. Okay, so that's why overall we have a concept here in Python. In Python, we have something known as ORC, known as object reusability concept. ORC is followed by the following objects. Number one, integer shall follow object reusability concept, which is, and it has got a range also. Integer, not all integers shall follow ORC. There will be a range of integers which will only follow ORC. That is from -5 to 256. Okay, this will follow ORC. Then you have Boolean values. There are two Boolean values only, true and false, that shall follow object reusability concept. Strings. The strings, they follow object reusability concept. And you have non-data type that also follows the ORC concept, that is object reusability concept. What do you mean by object reusability? Like for instance here, this 30 got reused. This 30 got created only once in this memory ID. Here we have got only one memory ID, and here this and here 30 got reused again and again. 30 can be reused by other variables also. If you create, say, z is equals to 30, then v is equals to 30, again and again it will be reused. Because why? Because 30, it lies within this range of integers. 30 is an integer, and 30 lies within this range of integers from -5 to 256. And this range of integers follows the ORC concept, object reusability concept, that in this scenario, that is within this range from -5 to 256, if you have created a value, and then that value will be created only once inside a memory ID, and then that value can be basically accessed by several variables. All right, it won't be recreated again and again at different memory IDs if you want to, if you want to create it again. Like here, x is equals to 30, y is equals to 30, but 30 got created only once at this memory ID, because 30 lies within that range of integers from -5 to 256, which follows ORC concept. That is, here the object can be reused again and again. It won't be recreated again and again. But here that is not the issue. Here x is equals to 12.5. So 12.5 got created at first, where at this particular memory ID, and then when I created y is equals to 12.5, then 12.5 actually got recreated again at a different memory ID, that is here this one. So here we have got two 12.5 values, because we have got two memory IDs. So here the object won't be reused again and again. Okay, it will be recreated, it will be actually recreated at different memory IDs, but that is not the case here. It won't be actually recreated again and again. It will be created only once and can be reused several times by different variables. But here the object will be recreated again and again at different memory IDs whenever you're trying to access it, whenever you're trying to access the same value by different variables. That is the thing. Okay, but not all integers follow. Not all integers follow the ORC concept. Only -5 to 256 range follows the ORC concept. Same with Boolean follows ORC concept. Strings follow ORC concept. None follows the ORC concept. ORC is not followed by the following objects. What are those? As I told you with example here, float. Float does not follow ORC concept. Complex does not follow ORC concept. Derived data types do not follow ORC concept. If you remember, derived data types like your list, tuple, dictionary, set, frozen set, range. These are the derived data types, and derived data types, they do not follow ORC concept. So every time you actually inside the program try to access the same value by different variables, then in these scenarios they will be recreated again and again at different memory IDs. And hence is operator if you want to use, then that shall return false. Okay, now here for example x, this here you have this small x is equals to capital X, which is capital X is what, a string value. Small y is equals to capital X, string value. And what do we have here? Strings, they follow ORC concept. So I'm writing here print x is y. It shall return true. It shall return true because strings, this is ultimately a string, and the string values they always follow the ORC concept. Print id of x, you see id of x is this value 2690633776624. Then print id of y. Id of y is also the same as that of id of x, which is nothing but the same 2690633776624. Because here what happens is that x, your x, it gets created only once. This string value, that is capital X, it gets created only once, where at this particular memory ID, that is this one. Now when I am assigning x, capital X to small x and capital X to your small y, then x won't be recreated again and again at different memory IDs. It is already there. Why? Because x is a string which follows ORC concept. X now can be reused by the small x, and x can be reused by the small y also. Okay, because ultimately x, this small x will have what? The small x will have this memory ID, and it shall point to this memory ID via which capital X can be accessed. Same with y also. Y also has this same memory ID, and y points out to this memory ID, and at this memory ID you have this particular string value x which can now be accessed. So that's why here you see x and y, both of them have the same memory IDs, and that's why it returns true, that yes, the memory ID of x is same as that of memory ID of y. Now here you have small x is equals to capital A string value, small y is equals to capital X. Okay, small x is equals to capital A and small y is equals to capital X. Now here definitely the two string values are different. Okay, so here what will happen is your A will be created, this string value A, it shall be created at a different memory ID, because I was talking about duplicate values. Okay, now here in case of different values, definitely A will be created at a different memory ID. For like for example here at this memory ID, A gets created. Okay, so now what will happen? X will have this particular memory ID, and X shall point out to this particular memory ID. And what will happen here? Ultimately, your string A shall be accessed. Okay, and what happens to Y? Y has capital X. Y has capital X. Okay, and where is this capital X? Capital X lies at this particular memory ID. And Y has this particular memory ID. And Y points out to this memory ID where you have capital X, and that capital X can be accessed. So in this scenario, X has this memory ID and Y has this memory ID. And you can clearly see the two memory IDs are different. So in this case, print X is Y. Is the memory ID of X same as that of memory ID of Y? No, it is false if you run this cell. Okay, then coming back to this particular cell, again you say x is equals to 256, y is equals to 256. It is the integers follow ORC concept, but the range of integers only follow the ORC concept, and the range is from -5 to 256. So that these range of integers follow the ORC concept. So here print x is y, it returns true, because this range of integers -5 to 256 follows the ORC concept. 256 here shall be created only once at this particular memory ID, and x shall have this memory ID, because I'm writing here what, x equals to 256. So in reality x will have this memory ID, it shall point out to this memory ID where you have 256. And y, I'm writing here y is equals to 256, so y will also have this same value, that is this same memory ID, and it shall point out to this same memory ID, and at this memory ID you have 256 that shall be accessed. So memory ID is one only, Memory IDs are always one. Okay, unique. Memory IDs are always unique. So here at this memory ID, you have 256 that can be accessed by these multiple variables, and both x and y have the same memory IDs. That's why returns true. Now, what will happen in this scenario? X is equals to 260, y is equals to 260. Integers, like these are integers, but you see here the range of integers -5 to 256 that follows the ORC concept. Here 260 is the integer value, and it is beyond this range of integers. Okay, 260, it lies outside the range of integers of -5 to 256, and that then what will happen, that will not follow the object reusability concept. So here what will happen, your at this particular memory id, when I'm writing x equals to 260, at this particular memory id 260 will be created, and x shall have this memory id, and x shall point out to this memory id, that is this one, and then only the value of 260 can be accessed. And again, when I'm writing y is equals to 260, then what will happen, 260 will be created again, 260 shall be created again at a different memory id. Here you see 260 shall be created again at a different memory id, and what will happen to y, y will have this new memory id that has been just created, where you have the second 260 value. Okay, so there are two 260 values. Okay, this is one 260, and this is the second 260, and both of them are there, recreated again. Okay, at first this got created at a memory id, then again a 260 got recreated at a different memory id. So two types of 260 values you have got lying at different memory ids, and that's why it returns false here. Print x is y, memory id of x is same as that of memory id of y, no, it returns false. And same happens here in this case also, float value, like here x equals to 8.7, y is equals to 8.7, float values do not follow the object reusability concept. So here 8.7, 8.7 are the same values, it appears, but in reality there will be two different 8.7 values created at two different memory ids. One memory id will be stored by x, another memory id will be stored by y. So here print x is y, it returns false, because y, memory id of x is different from that of memory id of y, because y, because of this float value. Okay, print id of x returns the memory id of x, that is what is the memory id that x is storing. Print id of y shall return what value of memory id y is pointing out to, it is this value, and you can clearly see these are different, that's why it returns false. Run this cell. Boolean values, in case of Boolean values, definitely they follow the object reusability concept, ORC. X equals to false, y is equals to false. False value will be created only once at this particular memory ID, and this memory ID will be pointed out or stored by X, as well as pointed out or stored by Y. So X and Y, both of them will have the same memory ID, that is this one, where you have false value, and X and Y, both of them shall point out to this same memory ID by which the false value can be accessed. So print x is y returns true. Memory ID of x is same as that of memory ID of y. Yes, it is true. And that can be checked by applying this ID function on x, as well as by applying ID function of y. Same memory ID values. None type, here xx is equals to capital none, yy is equals to capital none, and none data type follows ORC concept. So print xx is yy, that is memory id of xx is same as that of memory id of yy. It returns true, that yes, because why, because of the none data type. Double x and double y, both of them have the same memory id, both of them point out to the same memory id at which none is there, and that's why it returns true. Okay, now complex values, they do not return, they do not follow any kind of ORC concept. This is one complex value, this is another complex value. So one is stored by xx, another that is xx is equals to 16 plus 27j, and yy is equals to also 16 plus 27j. Please remember this is a complex value. So print xx is yy. So it will check, is the memory id of xx same as that of memory id of yy? Definitely not. it returns false because complex values, they do not follow ORC concept. So this first 16 plus 27J, it shall be created at this particular memory ID, and then this second 16 plus 27J shall be created again, recreated at a different memory ID, at this particular memory ID. So one memory ID is accessed, is stored by X, and another memory ID is referenced by Y, and the two are different. That's why it returns false. Now let us check here. Like for example, here you have X equals to, you have inside a list. This is ultimately a list, okay? And Y is equals to, this is also a list. Inside the list you have these values 10, 20, 30, 40. Here also same values 10, 20, 30, 40. Now what is a list? A list is a derived data type, and we already know derived data types, they do not follow the ORC concept, object reusability concept. So when you write this print X is Y, so definitely it will return false. Though outwardly speaking, you can see that okay, X inside X, you have this list having the same values as that of Y. Okay, in X you have a list where you have some values, and in Y also you have a list where you have some values, and the values are same. But you must remember, ultimately this is an entire list which is a derived data type. This is also an entire list which is a derived data type. So in case of derived data types, they do not follow ORC concept, and that's why the memory IDs will be different. So when you write print X is Y, it returns false here. And for cross check, you can use the ID function. Apply the ID function on X, print ID of X, and print ID of Y. You can easily see ID of X and ID of Y are different. ID of X is 269071646041 and ID of Y is 2690716434. Because this first list, this shall be created at this particular memory ID. Okay, that is 269, this one. And the second one, this second list shall be created at this particular memory ID. Okay, and memory IDs are pointed out or referenced by these two variables X and Y respectively, and both are different. That's why it is false. But now if I go inside the list, print X1 is Y1. Again you see, what is X1 here? What is X1 here? X1 is nothing but 10, isn't it? Because you see X1 is nothing but your 20. Sorry, X1 is 20. Because inside the list, if you go, then this value of 10, this value of 10 lies at what index position? This value of 10 lies at index position 0. Then 20, the second value, it lies at index position 1. Then 30, that is the third value, it lies at index position 2. And then you have 40, the fourth value, it lies at index position 3. So 10 is the first value which lies at index position 0, 20 is the second value which lies at index position 1, 30 is the third value which lies at index position 2, 40 is the fourth value which lies at index position 3. Okay, now same happens with in case of Y also. In case of inside the list of Y, when you go, you can again see that yeah, here also 10 is at 0 index position, 20 is at 1 index position, 30 is at 2 index position, and 40 is at 3 index position. You can see same, 10 is at 0th index position, 20 is at first index position, 30 is at second index position, 40 is at third index position. Okay, now if I print X1 is Y1 at index, these are index positions. Okay, it will go into X1. X1, what do you have at X1? At X1 you have 20. What do you have at Y1? At Y1 also you have 20. Okay, and 20, it shall be created only once at one memory ID, because 20 is an integer and it definitely lies inside the range of -5 to 256. Okay, so frankly speaking, this, suppose this particular memory ID is taken, this particular memory ID is taken, and here 20 gets created, 20 gets created at this particular memory ID. Okay, and 20, it is an integer and it lies within it lies in this range of integers from -5 to 256, and this range of integers follow the ORC concept, object reusability concept. Okay, So that means 20 won't be recreated. Here 20 has been created only once at this particular memory ID. And now it will be referenced or reused again and again by different variables. So here also it gets reused. Here also it gets reused. And it has been created only once at this memory ID. So now print x1 is y1. It returns true that yeah, x1 and y1 have the same memory ID. Okay, you can double check that also by applying the id function. Print id of x1, it returns this memory id. And print id of y1, print id of y1, it also returns this same memory id. So at this same memory id, 20 has been created, which is an integer that follows the ORC concept, object reusability concept, because it lies in this range of integers from -5 to 256. So it won't get recreated, it will be rather reused again and again by different variables. Okay, so x1 shall point out to this particular memory ID, and y1 shall also point out to this particular memory ID. Hit the enter button, yeah. Then another further you can check print x3 is y3. So what will happen? It will go to x, and then Python will check at the third index of x. What do you have at third index of x? At third index of x, you have what? You have 40, isn't it? This is index. It is at index position number 0, index position 1, index position 2, and index position 3. And at index position 3, you have 40. And for y also, it will check. Here for y also, index position number 3 will be checked, and here also you have 40. So x3 and y3, both of them will have the same memory ID, and that's why it returns true here, because 40 is also an integer that lies within this range of integers from -5 to 256 that follows the ORC concept. Okay. And yeah, for your practice purpose, you can try with this values of list that I've given here. X equals to 1100, y is equals to 1100. That is, sorry, here you have a list. Here you have a list assigned to x, and here also you have a list assigned to x. Inside the list, you have all these different values, 1100, then you have 200, 30, 40, same values repeated here in y also. And we already know the answer to this question. Print x is y. Answer is false. Though outwardly it may seem that the list contains the same values in both the scenarios. Here also the list has same values. Here also the list has same values. But in reality, the first list here shall be created at this particular memory ID, and the second list here shall be created at this different memory ID. And x shall be having this memory ID, and y shall be having this particular memory ID. So that's why print x is y shall return false, because both of them are having different memory IDs. Okay, you can double check that by applying the id function on x, as well as by applying the id function id function on y. Okay, why? Because list is a derived data type, and derived data types, they do not follow the ORC concept. But inside that if you go, you can check here, print x0 is y0. So what will happen? It will go to x, and at what index position Python will go? Python will go to the 0th index position of x. Okay, and what do you have at 0th position index of x? You have 1100. And it will go at the 0th position index of y also. There also you have got 1100. Now you are checking print x0 is y0. It returns false. It returns false. Why? Because here 1100 though is an integer, but it does not follow. It does not fall in that range of integers which follow the ORC concept. What is that range of integers which follow the ORC concept? -5 to 256. And 1100 does not fall in that category. So it does not follow object reusability concept. So 1100 will be here recreated twice at different memory IDs, and those different memory IDs will be accessed by x0 as well as y0, and that's why it returns false. And similarly, if you want to check x1 and y1, now go to x1. What is the it goes to x, and what is the value at first index position? It is 200 with respect to x. It goes to y also. At the first index position of y, what is the value stored here? 200. Now 200 is an integer that follows the ORC concept because it lies in that range of -5 to 256 where it follows the ORC concept. So in this scenario, 200 will be created only once at a memory ID, and that memory ID will be referenced by x1 as well as y1. So in this scenario, it shall return true, that yes, the memory ID of x1 is equals to the memory ID of y1. Okay. Similarly, you can use the is not operator also. Like for example, you have x equals to 170, y is equals to 170. Print x is not y. Is not shall return true whenever the memory IDs are different. Otherwise, it will return false. Okay. Now here you see print x is not y. That means I'm trying to say memory ID of x is not equal to the memory ID of y, and it says no, it's false. That means the memory ID of x is equals to the memory ID of y. Why? Because here you have this value 170, which is an integer that follows the ORC concept because it is in the range of -5 to 256. So it shall be created only once at this particular memory ID, and this memory ID shall be referenced by x as well as by y. So both x and y will have the same memory ID. That is this one. Okay. And for cross check, you can apply the id function on both x as well as on y. So if you run this, you get your answer. Okay. And then again, in case of is not also, print x is not y. Here what is x? X is equals to 1.4, y is equals to 1.4, and here what I'm writing, print x is not y. That means I'm implying here that the memory id of x is not equals to the memory ID of y, and it returns true, that yeah, you're correct. Memory ID of x is not equals to the memory ID of y, because here you have 1.4, which is a float value. Here also you have the same 1.4, but it is a float value which does not follow the ORC concept. So here 1.4 will be created at this memory ID, and this memory ID will be stored and pointed out or pointed and referenced by x. And again 1.4 will be recreated at a different memory ID, that is at this memory ID. This memory ID will be referenced by the variable y. So the first memory ID, that is this one, where you have 1.4, the first 1.4, it shall be stored by x, this memory ID, that shall be referenced by x, that shall be pointed out by x. And 1.4, when it is recreated again, it shall be recreated at a different memory ID, that is this one, which shall be stored by the variable y, that is pointed out by the variable y, referenced by the variable y. And both the memory IDs are different, that's why it returns true. And this true is returned when you are applying this is not operator. Okay. And just run this particular cell. Then here you have programming, and here again you have programming. And this is what? This is ultimately a string value. String values, they follow the ORC concept. And I'm trying to say here x is not y. That means the memory ID of x is not same as that of memory ID of y. It returns false, that no, the two memory IDs are the same. The memory ID of x is equals to memory ID of y, and that you can cross check by applying print ID of x, that shall give the ID of x here, and print ID of y, that shall give the ID of y here, and print x is not y returns the returns false here, because programming is a string, and strings, they follow the ORC concept. Okay. And then suppose here you have a dictionary, x equals to 3 is to 300, y is equals to 3 is to 300. And here I'm trying to say print x is not y, and it returns true, that yeah, x is not y. That is the memory ID of x is not same as that of memory ID of y. Why? The question is why? Because here you have a dictionary, and a dictionary is also a derived data type, and derived data types, they do not follow the ORC concept. Okay. And so two dictionaries will be created, one at this particular memory ID, that is this one, this memory ID, which will be the memory ID of X, and the second dictionary will be created at this memory ID. The second dictionary will be created at this memory ID, and this memory ID will be stored by Y, pointed out by Y, referenced by Y. So X and Y both of them are having two different memory IDs. Okay, the first memory ID is the memory ID of x that can be checked by applying the id function on x, and the second memory id is the memory id of y that can be checked by applying the id function on y. Okay, and just the same thing I've done here. You can just practice this one, x equals 2, and within the dictionary you have 3 is to 200, y is equals to 3 is to 200, print x is not y. Definitely it returns true. Definitely it returns true because of derived data type concept that does not follow the ORC object reusability concept, isn't it? So id of x and id of y, both of them will be your different. Now inside this, if you go, then print x3 is not y3. What is x3? X3 is nothing but your 200, because already I told you in case of dictionary, you can access a value by using the key. Okay, here we do not have any 0, 1, 2, any index position. Here, if you want to access a value, then for that you have to use the key. That is x3. So for example here, okay. And at x3, what do you have? At x3, you have this value 200. Similarly, similarly, at y3, what do we have? At y3, you have this value of 200. Okay, that is the here where 3 is what? 3 is the key. Where 3 is a key, it is not the index position. Now print x3 is not y3. It should return false. Yes, it has returned false. Print x3 is not y3, because what will happen as soon as I write x3, as soon as I write x3, then here in place of x3 internally 200 comes up. Okay, because what is the value of x3? Value of x3 is 200, where 3 is the key. What is the value of y3? It is also 200. And what is 3? 3 in this case is a key. 3 in this case is also a key. That is inside x and inside y. Okay. Now further what will happen? I'm applying the is not operator. So as soon as I'm applying the is not operator, the memory ID of 200 will be checked. Memory ID of 200 will be checked, and memory ID of this 200 will be also checked, and both of them will be same, because 200 is an integer that follows in that range of integers from -5 to 256. You can see here the 200, when is not operator is applied, memory ID of 200 is returned here, which is this one. And for this, that is for with respect to x3, and with respect to y3 also 200 when it is returned, then and I'm applying is not operator, then in place of 200 its memory id shall also be returned. Now the two memory ids are checked, and that's why it's you can clearly see here the two memory ids are the same. These two memory ids, they are the same. And the is not operator, it will only return true if the two memory ids are different, otherwise it returns false. False is returned when? In case of is not. In case of is not operator, the false is returned at that scenario when the two memory IDs are the same. Okay, that's why here it returns false. The is not operator here returns false because the two memory IDs here are the same. Okay, and you can further cross check it. Q is equals to x3, so Q will have this value of 200, and W is equals to y3. W will also have this value of 200. Okay, so print Q is W. Print Q is W. It returns true. That, yeah, it returns true because ultimately 200 will be stored at this particular, say, memory ID. Okay, and it shall be created only once at this particular memory ID, and this memory ID is now stored by Q as well as by W. And Q and W, both of them are referencing to the same memory ID, and that means both of them are having the same memory ID. So print Q is W returns true here, and you can check that by applying the ID function on Q, that returns this memory ID, as well as by applying the ID function on W, that returns this particular memory ID. Okay, so like every time you run it, this thing happens that every time you run it, the memory IDs change. Only the memory IDs change. Okay, every time you run it. So that's it for this class. If you have liked this, then you can hit the like, share, and subscribe button and press the bell icon for further notifications. So thank you.